In this video, we're talking about division of rational expressions. And remember, when we talk about rational expressions, we just mean a fraction where the numerator and or the denominator is a polynomial. So instead of just a regular fraction like 3/4, we have here a fraction where the numerator is a polynomial and the denominator is a polynomial. And we're going to be dividing rational expressions. So this is one rational expression. It's a fraction with polynomials in the numerator and denominator. We're dividing that by another rational expression. So how do we go about simplifying an expression like this one? Well, it's simple. We turned it into a multiplication problem instead of a division problem. And we've already talked about how to multiply rational expressions. So how do we go about changing the division into multiplication? We just take the fraction that's being divided, the second one here, and we flip it upside down. We take its reciprocal. So we just make the numerator and denominator change places, and by doing that, we get to change the division to multiplication. So this actually becomes x squared minus 6x plus 8. We keep the first fraction exactly the same, x squared plus 3x minus 28. And instead of dividing, now we're going to multiply, and we just flip the second fraction upside down. So the numerator is now going to be x squared plus 2x minus 35, and the denominator will be x squared minus 2x minus 15. So we just flipped it upside down and changed the division to multiplication, and we can do that every time. It works every time. So now, instead of a division problem, it's a multiplication problem. And how do we deal with multiplication of rational expressions? Well, normally we would just multiply the numerators together to get the new numerator, and we would multiply the denominators together to get the new denominator. But these are fairly complicated equations, so what we want to do before we just proceed with our multiplication is to see if we can simplify these expressions at all, if we can cancel anything from our fractions before we do the multiplication. Because these are trinomials, there's a good chance that we might be able to factor them. So let's go ahead and look at that. If we try to factor x squared minus 6x plus 8, we're going to get x minus 4 times x minus 2, because negative 4 times a negative 2 gives us a positive 8, and negative 4 minus 2 gives us a negative 6, which is what we need in the middle. Looking here at the denominator, x squared plus 3x minus 28, factors of 28 are going to be 7 and 4. So we want x plus 7 times x minus 4, and double checking ourselves, positive 7 times negative 4 gives negative 28. Plus 7 minus 4 gives us positive 3. So looking at the second fraction then, we want to see if we can factor. X squared plus 2x minus 35 looks like it'll factor into x plus 7 times x minus 5. Positive 7 times negative 5 is a negative 35. Plus 7 minus 5 is a positive 2, so we're good there. And then x squared minus 2x minus 15 will be x minus 5 times x plus 3. Negative 5 times positive 3 is a negative 15. Negative 5 plus 3 is a negative 2. So we're good there. So now what we want to do is see if we can cancel within our fraction. So if we look at our first fraction, we can see right away, x minus 4 in the numerator, which will cancel with x minus 4 in the denominator. When we have those common factors across the numerator and denominator, they'll cancel with one another. Looking at our second fraction here, we can see that we have x minus 5 in the numerator and denominator, so we'll get those to cancel. So we've canceled within our fractions, but what about now canceling across our fractions? Because these are multiplied together, they're all going to meld into one fraction, so I can cancel like terms in the numerator and denominator. So I can see I have here x plus 7 in the denominator and x plus 7 in the numerator, so those will go away, and all I'm left with then is x minus 2 over x plus 3. Let's do another example here. I have x squared minus x minus 6. Let's see if we can factor that as x minus 3 times x plus 2, and that'll work. In the denominator, x squared minus 6x minus 16, we have x minus 8 and x plus 2, which will work. And then instead of doing division, we're going to do multiplication, and we're going to flip this upside down. So x squared minus 3x minus 40 will move into the numerator, and we should be able to factor that as x minus 8 times x plus 5. And then in our denominator, the x squared minus 3x will move into the denominator. It's not a trinomial, so we can't factor it as we've been for these other trinomials, but we can still pull out an x. So x squared minus 3x is the same thing as x times x minus 3. So now we'll look within our fractions and we can see we can cancel an x plus 2 with an x plus 2. We can't cancel anything within the fraction here, but looking across the fractions, we can see we can cancel an x minus 3 with an x minus 3, and we can cancel an x minus 8 with an x minus 8. So now this whole fraction, the first fraction, has been canceled. So essentially we have 1 times whatever's left in the second fraction. So we can just look at the second fraction and say that our final answer is going to be whatever's left over, which will be x plus 5, all divided by x. So again, the key with division of rational expressions is just going to be turning them into multiplication problems instead of division problems by taking the reciprocal of the second fraction here. And then instead of just multiplying across numerators and denominators together, we want to see if we can factor, if we can cancel like terms within the fractions, if we can cancel like terms across the fractions. And then after we do our cancellation and we've simplified the fractions as much as possible, then multiplying across the numerators together and the denominators together to get the final answer.